A heuristic approach to explain why the denominator of the sample standard deviation is written as n-1. Using the concept of degrees of freedom in statistics allows us to explain most quickly why the denominator of the sample standard deviation is written as n1, but it takes much more time to understand what degrees of freedom actually means. Therefore, I will use the error between the sample mean and the population mean to demonstrate. First, we use x bar to represent the sample mean, and use the Greek letter mu to represent the population mean. According to the Central Limit Theorem, the standard error of x bar is sigma over the square root of n, where n is the sample size std. Error of mean. From this formula, we can see that as n approaches infinity, the limit of x bar will equal mu. This is why the larger the sample size, the higher the accuracy. However, in the case of a limited sample, from the viewpoint of expected value, each subtraction accumulates a variance of sigma square over n, and with n samples, this accumulates to sigma square. What we need to correct is precisely this sigma square. I use a trick with the expected value. I replace the sample with n over 2 values of mu plus sigma and n over 2 values of mu minus sigma. You can clearly see that the mean of these numbers is still equal to mu, and the standard deviation is still equal to sigma. Similarly, I use mu plus sigma over square root of n and mu minus sigma over square root of to replace the expected value of x bar. You can clearly see that the mean of these numbers is still equal to mu, and the standard deviation is still equal to sigma over square root of n. The algebraic operations below directly demonstrate the accumulation of this error. Each subtraction accumulates a variance of sigma square over n, and with n samples, this accumulates to sigma square. What we need to correct is precisely this sigma square.